Welcome to this video. I am Dr.K.Usha, Assistant Professor of Statistics, Sri Sharada College of Humans, Salem. So in this video, I am going to talk about real number system as an order field. So what do you mean by real number? Real numbers can be referred as the union of both rational and irrational numbers, which can be both positive or negative and are denoted by a symbol R. All the natural numbers, decimals, and fractions come under this category. So that's why we are taking real number for all the analysis. So in this video, we are going to see about all the field for real numbers. So before going to this video, first we will see the so first we will see that what is meant by field. In real analysis, a field is an order set that is closed under the operations of addition and multiplication. So now move on to it means the field should be satisfy the addition and multiplication operation. So that thing only we are going to see about in this video. So start let R be the set of real numbers and the two binary operations addition and multiplication be denoted by plus and dot respectively. So we know about the two binary operations. First one is addition which is denoted by plus and multiplication which is denoted by dot. So these two binary operations satisfy the following condition. Then we say that given real number is the algebraic structure and also a ordered field. Then the algebraic structure means r comma plus comma dot satisfy the following axioms. If we satisfy all the axioms, it is the algebraic structure. So first we see the field axiom. First one is addition axiom. So for there are four types of axiom. First one is closure law of addition, commutative law of addition, then associative law of addition, additive additive identity, then existence of additive index. There are five. The five axioms are there. So the addition should satisfy all the five conditions. It should follow the multiplication also. So first of all, we will see the what is mean by closure law for addition. The sum of any two real numbers will always be a real number. That is, if A and B any two real numbers, A plus B will be the real numbers. So closure property holds for addition and multiplications of real number, which means closer to the from closer to the binary operations. So first one we take the addition. So for given a comma b, for all a comma b belongs to real numbers, which means a and b are two elements which is also a two real numbers which is belongs to the set of real numbers R. If we take any two real numbers a comma b, when we add or sum of these two real numbers, that answer also will be in the real numbers. For example, for a I can take 1, for b I can take 2. So now add to two values, 1 plus 2 is the 3. So in the real number, a value is 1, 2 and the result will be 3 also in the real number system. So this is the closure law of addition. So next one is the commutative law of addition. So commutative law of addition in addition means if we have any two real numbers a and b, then either we add them a plus b or b plus a, then the result remaining the same. So which means if we have two elements a comma b which is belongs to our real number, the two real numbers a comma b when we add a plus b or b plus a any order, the result will be the same on both sides. For example, for a equal to 2 plus b equal to 3, so what will be the answer? 5 this part left hand side. When see this side, so b value is 3, then a value is 2. So now we sum this value. What is the answer? 5. So when we change either a plus b or b plus a, we will get the same answer. That is the commutative law of addition. So next one, associative law of addition. So associative law of addition means it tells about when any three real numbers are added, that the grouping or association of the numbers does not affect the result, which means for the associative law of addition, we need any three real numbers a comma b comma c, which is belongs to R, which is set of real numbers. Here we can change the order a plus b into b plus c, which is equal to a plus c plus c. For the right hand side, see that a plus then b plus c. First we are adding this side b plus c, then add with a. This side, first we are adding a plus b, then add with c. This is the associative law of addition. For example, a equal to 1, b equal to 2, c equal to 3. So first we add the b plus c. 2 plus 3 is 5 plus 1 plus a value is 1. The answer is 6. Then come to this side. A value is 1, b value is 2. So 1 plus 2 is 3, plus 3 is c value is 3. So the answer is 6. So when we arrange the order, we will get the same answer on the both the sides. That is the associative law of addition. So next one is the existence of additive identity. So existence of additive identity means, so 0 is called the identity element and also known as the additive identity. For addition, we are taking 0 is the identity element or additive identity. If we take any number with 0, if we add any number with 0, the resulting number will be the same number. This is for any real number. So for this, so for us A belongs to R. We are taking A is the real number. There exists 0. 0 also belongs to R such that A plus 0 equal to 0 plus A equal to A. This real number 0 is called the additive identity of R, which for example for A value I am taking 1. 1 plus 1 equal to 1 plus 0 equal to 1. 0 plus 1 equal to 1. If we take any real number, when add this to 0, we will get the same number. That is the additive identity. For addition, we are using for additive identity as 0. In the multiplication, we are taking multiplicative identity as 1. When come to multiplication, we will see in the details. So next one is the existence of additive inverse. So existence of additive inverse means the then you said a real number is a opposite number. One real number has the opposite real number. When we add the two numbers, we will get the sum of both the numbers become 0, which means so which means the real number b is called the additive inverse of a, which means a inverse of a is b. That is this meaning for this line. But a plus b equal to 0, which is equal to b plus a, which means b equal to a. That is additive inverse of a real number. A is negative, thus a plus minus a equal to 0 is equal to minus a plus a. So the additive inverse for a real number is a minus a. When we add this a minus a with plus a, we will get the answer is 0. That is the existence of additive inverse. So next one is the multiplication of maximum. So far we have seen that present, closer, commutative, associative, existent, and existent law of multiplication, and then inverse identity for addition. Now we are going to see about the same laws for the multiplication, which is closer, commutative, associative, existence for identity, and inverse for the multiplication axiom. Let's see one by one. So first one is the closer law of multiplication. The product of any two real numbers will always be a real number. That is, if A and B any two real numbers, A into B will be a real number. So here we are taking A and B two real number which is belongs to R, which means the set of two real numbers belongs to the two elements which is belongs to the set of real numbers of A dot B, which is belongs to R, which means here I am taking A value 2, B value is 3. When we multiplied A into B, that is we get the 6. So 2, 3 and the result 6 also in the set of real numbers which is in the R. That is the closer law of multiplication. So already we have seen in the addition, which is closer of law of multiplication in which the addition and multiplication operation is closer to the value, that is the closer law of multiplication and addition. So next one is commutative law of multiplications. Commutative law of addition. Law of multiplication means if we have two real numbers a and b, then either we sum multiply the a into b or b into a, the result remaining the same. So that is the commutative law of multiplication. Here we are taking two real numbers a b which is belongs to R set of real numbers. Here a dot b equal to b dot a, which means we are first we are for a we are taking 2, for b I am taking 4. So 2 into 4 8, which is equal to 4 into a, 4 into 2 also 8. So if we change the a into b or b into b a, we can take any multiplication a into b or b into a, we get the same answer. That is the commutative law of multiplication. So this value is also in the set of real numbers. That is the commutative law of multiplication. Then next one is the associative law of multiplication. So, associated law of multiplication states that when any three real numbers are multiplied, the grouping or association of the numbers does not affect the result. So, for that associative law of multiplication, we need three elements a, comma b, comma c, which is belongs to set of real numbers R. Here we are changing the order a into b into c, which is equal to a into b into c. You can change the order, the result will be the same. For example, I am taking for a1, b2 and c3. So first we are multiplying b and c. What will be the answer? 2 into 3, 6. Then 6 into 1 is 6. Then come to this side. Here a is 1, b value is 2. So 1 into 2 is 2. Into c value is 3. So 2 into 3 equal to 6. So here we are changing the order, but what will be the answer? The answers are remaining the same. That is the associative law of multiplication. The associative law of multiplication. So next one is the existence law of multiplication. So we already seen this existence law, law of addition. So there we are taking the value for 0. So in the multiplication we are taking 1. So identity here is 1. So what is mean by existence law of multiplication? So one is called the identity element, also known as the multiplication identity. If we multiply any number with 1, the resulting number will be the same number. This is the multiplication of identity. So see this here, A belongs to R, there exists one which is belongs to R such that A dot 1 equal to 1 dot A, which is equal to A. This real number 1 is called the multiplicative identity of R. Already we have seen that any element, any two real numbers or one real number we are taken from the set of real numbers, it should be there in the real numbers. Here also same. So here I am taking A value is 5, 5 dot 1 equal to 5, 1 dot 5 equal to 5. That is the identity of multiplication law. So here see the I'm taking 5. The result also 5. The both will be in the set of real numbers. So this is the existence law of multiplication identity. So next one is the existence of multiplicative inverse. So in the addition also we have seen that, and yes, in the addition also we have seen the existence of addition inverse. In that case we are using if we taking a inverse is minus a, then means for addition we are subtracting the inverse a minus a equal to 0. In the multiplication we are taking divided. So if for example a into 1 by a, so here a is the multiplication on real number, then inverse is 1 by a. That is the existence of multiplicative inverse. If okay, if it is opposite number, if a number is multiplied which means divided number multiplied with the multiplicative inverse, then multiplied of both the numbers become what will be the answer? 1. So when we for example, a belongs to R, which is a not equal to 0, there exists b belongs to R such that a dot b equal to b dot a equal to 1. So for example, we can see that a equal to for a value I am taking 5, for b value what is the A inverse? Here A is 5. The inverse is 1 divided by 5. So A into B means 5 into 1 divided by 5. This is equal to B value is 1 divided by 5 into A value is 5. So 5 cancel. The result will be 1. So when we multiply with the inverse, we will get the 1 answer. So real number B is called the multiplicative inverse inverse of A, and it is denoted by A inverse or 1 by A, which is the reciprocal of A. So that's all about the um, inverse of inverse of multiplication. So these all are the we have seen already seen for addition and multiplication. There are five conditions. So this condition should be satisfied for the real number. Then one more is the distributive. So distributive means multiplication distributes over addition in R. Here we are doing multiplication and addition same time. For D for all A comma B C belongs to R, we are taking three real numbers A, B, C from the set of real numbers. Here we are doing addition and multiplication. A dot into B plus C equal to A dot into B plus A dot into C. So for example, A equal to 1, B equal to 2, C equal to 3. So B plus C is 2 plus 3, 5. 5 into 1 is 1, 5. Here A dot 1 into 2, 1 into 2, 2. Here 1 into 3, so 2 plus 3 is 5. So this is the distributive. Okay. So, so we are come to the conclusion. So when we say that given field is an order field, it should be satisfy the all the above axioms. Then we say that the given field is an order field. So a non-empty state with at least two elements, it is in it and with two binary operations satisfying all the above 11 axioms A1 to A5 and M1 to M5, and D is called a field. So, above is the example for real analysis, or comma, addition and multiplication. Then Q means Q comma, addition and multiplication is also a field, whereas Z plus Z plus comma dot and N comma plus comma dot or not so. For example, what is the given num? Rational numbers and real numbers are also a field. When come to natural numbers and integer, it is not a field. So if you want to know about how, so the real number satisfy the order field or the aximum. Same thing, the rational numbers also Q also satisfy the all the aximum, but that natural numbers and the integers not satisfy the all the aximum. So if you want to find about how, you can refer this book. So for this video I am referring this book. So from this you can get more information about order field about the real analysis. In this video, I am focused only for real numbers. If you want to know about rational numbers, irrational numbers, whole numbers, integer numbers, natural numbers for order field, you can try yourself or can refer this book. Thank you for watching this video. Thank you.